Hi there. Today we're going to look at a question which is based on how we are going to calculate the probability of a type 1 error as well as the probability of making a type 2 error, and this is for a normally distributed situation. A random variable x is just normally distributed with mean, mu, and standard deviation 5. The null hypothesis, which is basically HO, HO, null hypothesis, mu is equal to 35, is tested against the alternative hypothesis mu being less than 35 using a sample size of 30. Now, it is agreed to reject the null hypothesis, to reject HO, if the sample mean is x bar, is less than 33. Now, first of all, we have to calculate the probability of type 1 error. So to do this, first of all, what I'm going to do is probability of a type 1 error. What is this basically? What does it mean? It means that we're going to reject, probability to rejecting HO, given that HO is true. So that's the probability of a type 1 error. So we're going to reject HO, and when are we going to reject HO? It's going to be rejected here. When the null hypothesis, that is HO, null hypothesis, if we're going to reject HO if the sample mean, that is x bar, is less than 33. Given that the mean is true, given that the mean is basically now 35. So what we just need to do, just standardize. But when you standardize, there's something I want you to remember, is that we're looking for less than 33. So this is probability of z being less than 33 minus 35 over the standard deviation, which is basically the variance, and the standard deviation is 5 here, so that's 25 over 30. The sample size is 30, and then you just do that on your calculator. So this is going to turn out to be z being less than, okay, let's do it in my calculator. Here we are. So we have -2, and that's being divided by the square root of 25 over 30. That's going to be minus 2.1908. So minus 2.1908. And if we were to do this, now you're going to have to standardize. So what I want you to remember is this is where your region is. Minus 2.1908. Remember, this is HO, and this is H1, and this is as well as H1. But now, if you were to standardize this, so what you should do, you should reflect it on the other side, and you come here. So this is where your H1 is. That's where your HO is. And now what we're going to do is we're going to put this as a positive value, 2.1908, and so we have probability of z being greater than 2.1908. And if you look at this from your calculator, we're going to go to normal distribution, cumulative distribution function. So this is 2.1908. We're looking at something like 0.1423 and so on. So let's say approximately 0.0142. And so this is our probability of a type 1 error. So what do we mean by this basically? When we reject HO, it means that we are accepting H1. So H1 is here, so the null hypothesis is rejected. So you're accept H1. That's the message. You accept this because you're saying that this one's okay, when in fact HO is the one that is okay. So you're rejecting this, you're accepting this region. This region here is being accepted. So this region, the area is 0.0142. So this is your probability of type 1 error. Now immediately we're going to move on to probability of a type 2 error. So let's talk about this. When we said type 1 error, it was agreed that the mean would actually be less than 33. So what about probability of a type 2 error? That's the opposite of a type 1 error. So it's going to be then greater. So the sample mean is now going to be greater than or equal to 33. And that's going to give us the probability of a type 2 error. Let me just do it over here. Probability of a type 2 error. So let's look at the definition. It's probability that we are accepting HO, given that HO now is false. And now given the mean mu, the actual mean is now 34.2. That's the actual mean. So we're going to be using this mean to calculate our probability of type 2 error. And therefore, the sample mean X bar will be now greater or equal to 33, which is the opposite of what we did when we calculated the type 1 error. So I'm going to say probability of a X bar being greater than 33 now. Okay, and we're going to standardize this. So if we were to standardize this, here we are. Greater than 33, I'm going to say then probability of Z being greater than 33 minus now the actual mean, and the actual mean mu is given as 34.2. So minus 34.2 and divided by the square root of the variance, which is 25 over your sample size. So let's do this on a calculator and see what we get there. Right. So this is going to be 33 minus 34.2, which comes as a negative 1.2, and all of that divided by the square root of 25 over 30. And this is going to be minus 1.3145 and so on. So if we standardize this, remember from your standardized diagram, the mean is always 0. Negative 1.314 is somewhere here. Negative 1.314 or maybe 5 and so on. So less than that's going to be on this side. No, I mean greater, sorry, greater. So we're looking at something greater. And so what we can do, we can flip this over, turn this into positive, negative, and then here we are. So this is what we need. So 1.3145. So we're accepting this region there is being accept this region, HO region. That's basically your type 2 error. Here. So are we saying then probability of Z being greater? All right, so now being less because you flipped it over, so it's going to be less than 1.3145. You can look at this value from your table to find its probability, but I'm going to look at the calculator here. So I'm just going to go into the distribution, normal distribution curve, and for cumulative one, we're looking at 1.3145 and 500. So that's going to be then 0.1 minus 0.9 Okay, hang on a second. Spell 1 minus. So if you were to look at this, you're going to get phi of 1.3145 and turns out to be 0.9057. It's a very huge area, makes sense to me. So this is your probability of a type 2 error. And here we are. I hope this video makes sense and that you've been able to actually get some knowledge of how to calculate probabilities of a type 1 and type 2 errors for a normal distribution. Okay, thank you for your attention. Take care.